Hey guys, Sometimes Crazy here, back with another video. This will be episode 6 of Krunker Science, and as you saw by the title of this video, today I'm going to be working out how much Krunker Guy weighs, and I just want to get this out of the way. This video has been probably over about 3 months in the making. It's been a very long time, and that is because working out weight is usually really easy, right? There's really easy methods to do it, but seeing as we're missing so many values that would make it easy, it's made it a lot more difficult, if you know what I mean. So for example, you know that 2 plus 2 equals 4. It's a very simple example, but imagine you didn't have the second 2 and didn't have the answer 4. So what you were looking for was 2 plus something equals something, and it could literally be anything. That's sort of the dilemma I've been facing. Also, before we get into the theory, I think it was a few videos ago in episode 4, I established that gravity in Krunker was actually stronger than Earth, and that's not entirely true. I just simplified it by saying gravity was stronger, but gravity is actually exactly the same. So, imagine a childhood experiment for centrifugal force. You know, the one where you fill a bucket with water and you spin it around above your head, or you can hold it out and spin in a circle, you know? In that experiment, the water stays in the bucket, right? Well, imagine the person who's swinging the bucket, i.e. you, is Earth, right? And so gravity, when the bucket is directly above your head, is going to be making the water want to fall on top of your head, right? So the water inside is everything on Earth, and the bottom of the bucket is going to be the atmosphere. So the faster that the bucket spins, the more it gets pulled out towards the bottom of the bucket, i.e. the atmosphere in this example, and so the less will fall out on top of you. In fact, none if you're doing it fast enough. Whereas if you slow that down, there's going to be a lot less keeping it up towards the bucket, and so a lot more force is going to be pulling it down, which is essentially what's happening on Krunker. So because the Earth is spinning a lot slower, I think I said it was only around 3 miles per hour or something like that, that means that the centrifugal force is going to be a lot less, so you're going to get pulled down to Earth a lot more, which would still have the same evolving shorter effect as I put in the video. I just simplified it a bit, where I really probably shouldn't have done, because it's just caused confusion. Anyway, I'm just going to, because gravity's the same and it's just centrifugal force, it means that we do actually have a shot of working out the weight of Krunker Guy. As I said before, strap in. I've been working for like 3 months on this video. This was the video I actually wanted to make first, before any of my other science videos, but it just took so long. Like, there was so much that I had to do, and so there is so much more maths in this than I usually do in a video. So the first thing I had to do in this is work out the terminal velocity of Krunker Guy. So terminal velocity is the fastest that a object can fall without being propelled like further. So for example, that's how bugs can survive long falls. So bugs are so small that they can't get the speed up to splat when they hit the ground. So a bug could jump off of your house and land on the ground fine and nothing would happen, because it's just not heavy enough and there's not enough mass to get it quick enough to hit the ground and splat. But if you jumped off of the top of your house, which I'm not saying do, then you definitely splat when you hit the bottom, because you're big enough, you've got enough mass to like have a fatal terminal velocity essentially. So the way I worked terminal velocity out was that I set a wall, and I coloured this wall blue, and I set that as 1,000 pixels. Then I dropped Krunker Guy from various heights, and when his crosshair first hit the blue, I'd start a stopwatch, and when it left the blue, I'd end the stopwatch. So up to around 9,000 pixels, Krunker Guy was falling much slower at 1,000 than he was at 9,000. Past 9,000 pixels, because I did it up to about 20,000, the results were so comparable that 9,000 was really the sweet spot. It was the lowest I could go with the same terminal velocity. So, using this, I will drop Krunker Guy from 9,000 pixels, and then the last 1,000 was the blue wall I was telling you about. And I'd use a program called Splits, which is used by speedrunners to get the times on the screen. So there'd be a hotkey to start the time and a hotkey to stop the time, and it'd be on the screen the whole time. I averaged that he fell at the fastest speed, which I believe not to be a false positive, of 2.61 seconds for 1,000 pixels. The reason I say false positives is obviously there is so much room for human error. I had to click it as fast as I could when I thought his crosshair was on it, and as fast as I could when I thought it was off of it. And so there were some results I got which were down in like 2.3, 2.4, which are definitely false positives, where I've started it late and ended it early. And there's ones that are up in like 3.8 seconds because I've started it way too early and ended it too late. So I'm confident that 2.61 seconds was my most realistic time. So to find out, because 1,000 pixels is 300 feet, but he fell at 2.6. He fell for 2.61 seconds. So to find out the terminal velocity in feet per second, we have to divide everything by 2.61, so the time it took. So 2.61 divided by 2.61 is 1, and 300 divided by 2.61 is 114.9 recurring. But obviously 0.9 recurring, it is in all sense of the word, is 115. So for simplicity, I will be rounding up to 115. So this makes terminal velocity for Krunker 115 feet per second. So then I was using NASA's equation for terminal velocity, because we can actually reverse engineer the equation to find weight from terminal velocity. We could do that, but thanks NASA for doing it before me, so I don't have to, work it out myself. So if you see the page here, specifically I'll be focusing on this equation in the middle. And it might look confusing, but I'm going to break it down for you. So to find the weight, I'm going to have to use various calculations and things like that. And so first I'm going to look at A, which is frontal area. So frontal area is the area facing the direction of drag. Now, drag is a force pushing against anything that's moving. So if you're moving forwards, there's always going to be drag pushing you back. You can really feel drag if you've ever tried to walk in a swimming pool. Do you know when you're walking outside of a swimming pool or any body of water, it could be the sea, swimming pool, pond, whatever, it's easy to walk outside. When you get in, your legs feel a lot slower, and that's because water's pushing against it. That's what drag is. So aeroplanes in the sky will have the same thing but with air pushing against them, which will slow them down. So frontal area is the area that drag is hitting. Now, the area that drag is hitting is quite strange because it's not just flat areas. So, Krunker guy is going to be falling with his knife out. Now, that's important because Krunker guy falling with his knife out has a different area than Krunker guy falling with his AK out. And I know that won't affect the speed per se, it's just a lot easier to work out. You'd have to work out the feet, because if you're looking from the direction of drag, which is bottom, you're going to be looking straight up, like it's a 2D image. You're going to see feet, then you're going to see the outline of the head, and then you're going to see the bottom of the arms, ranging from the top of the fingers down to the backwards to the top of the arms. It's quite strange because he's got them in like a right angle sort of thing, but you're going to be looking for the down up in a 2D sort of fashion. We don't actually have to work out the feet because we could just work out the head, because that overlaps the feet. So just working out the head and then the feet separately. So after I've done that, I've worked out that it's 51.84 inches squared for the head, and each arm is 14.4 inches squared. And when all added together and converted, that's a total of 0.56 square foot. So now we've got the coefficient drag. As I explained before, it's a different type of drag. It's a bit, I don't know how to explain. It's a bit weirder. I'd never actually heard of this type of drag before. I had to look it up. But it's quite universal, really. So according to the OpenStax Physics Understanding Drag page, the coefficient drag of a circular plate is 1.12. I'm going to be using 1.12 because a flat plate assumes that flat surface is always facing a drag. And because Krunker doesn't move or tumble through the air, he's always going to be essentially a flat surface hitting the air. Like if you dropped, for example, a brick out of a window, that's going to tumble and fall as it goes, making the coefficient drag a lot different. But Krunker stays completely stationary, meaning that we can just use the 1.12 coefficient drag value. So, thirdly, we've got gas density, and that's represented in this image as a weird P. That's actually the Greek symbol Ra, so from now on it's going to be referred to as R. The gas density is it's just the density of air, which is approximately 1.247 kilograms per meter cubed. I'm going to be using this because gas density actually relies on air temperature and not height like people think. So for example, people think that the higher up you are, the lower the thinner the air, And that is true. The gas density is a lot lower when you're higher up in the air, but that's not because of the height. That's just because it's a lot colder. And we've actually really lucky because we worked out that Krunker is set in Bulgaria. Bulgaria has a very accurate. They've been keeping accurate records of meteorology since the 1700s. So, from the year 1743 until 2015, the average air temperature was 10.49 degrees Celsius. And because the standard of air density states that at 10 degrees Celsius the air is a density of 1.247 kilograms per meter cubed, we can use this because we're just going to be rounding down by 0.49, which isn't much to round down by at all in the grand scheme of things. We could work it out, but when I worked it out, I actually got to 1.247000314, so it would have been rounded down anyway. Finally, we've got the velocity, which we've already worked out. The velocity is the terminal velocity, which is 115 feet per second. That's the velocity that's needed for this calculation. So using all this, we can actually apply the values we need to work out the weight of Krunker Guy in the formula shown before. CD times R times v to the power 2 times A divided by 2 equals W, which translated from algebra is a coefficient drag times gas density times velocity squared times frontal area divided by 2 equals weight. So you can actually get multiple values if you approach this in different ways, and a lot of them are going to be wrong. So you don't actually approach it from left to right. You don't do coefficient drag times gas density, then times velocity and square all that. No, you have to approach it properly. And the way I was always taught in school was BIDMAS. And that stands for brackets, then indices, then division, multiplication, then addition, subtraction. And this is just stating the order of approach to a mathematical equation, from B being the first thing that you focus on, and A and S being the last ones. So looking at this equation, we can see there are no brackets in it, so we start from indices, which is anything involving powers. So that means that we do 115 squared, which is 13,225. Then we do 1.12 times 1.247 times 13,225 times 0.56. Then we get quite a long value of 10,343.51584. So then we just divide 10,343.51584 by 2. And we get the answer in pounds. We get the answer in pounds, which means Krunker Guy weighs 5,171.75792 pounds, or this is a lot easier to say. He weighs approximately 369 stone and 6 pounds. Like, Jesus. I mean, just because of a comment I got on my heights video about not including height in meters and stuff like that, I have converted it, and it equates to roughly 2,345.869931,999 kilograms. But that's right, Krunker Guy, he dwarfs the existing record for weight, which was held by John Brower Minnock, who weighed approximately 1,400 pounds. To illustrate the scale of what we, of how heavy this is, I mean, we can already tell it's heavy. Collectively on Earth right now, if everyone stood on one giant scale, everyone on Earth, we would all weigh collectively approximately 632 billion pounds, which is insane. As of February 2020, there are around 7.8 billion people on Earth. We can imagine that Krunker Guy lives in a similar population planet. So, if he does, then collectively, their population, instead of weighing 632 billion pounds, they weigh 40,338 billion pounds. Alright, thank you guys for watching this video. Sorry that it's a day late, I'm recording this now on Monday, just finishing up the editing. I would have liked for it to have been released yesterday on Sunday, but as I said before, I've been on this theory for such a long time. Really wanted to get the video as good as it could be, and I'm really happy with how the video's turned out. Also, again, as I say, every single episode, I'm really happy with your guys' continued support of the series. Really helps me to motivate me to make more videos like this. Yeah, also my channel has had a little bit of a revamp. You might have noticed, probably not, but I have a new profile picture which I made myself. It's just whatever. I mean, I just didn't like the old one, so this new one, it looks kind of terrible, but it's way better than the old one. But courtesy of Koala or HappyLemon, you might know him. I'll link him down below. He made me this new outro you're going to see, and the new banner, which is VHS themed for my YouTube channel, which I'm super duper happy with. So yeah, go check him out. He's dead cool. Yeah, so I guess I'll see you guys in the next video. Thanks.